Alright, so in this video what we're going to be doing is we're going to be hooking a PowerFlex 525 to Plant Packs. And we're going to be doing this in this video, showing you exactly the way that the tag structure is so you can be successful at doing this yourself. So just to show you a couple different things, we're going to come into our program here and I'm going to show you how I synced everything up. Okay, so this was a demo. Yes, it was a demo that I got from Plant Packs, and I've kind of tweaked it a little bit, but I've also kind of, just streamed and kept it as like the same thing you can get from Rockwell, and that way you can be successful at doing this as well. So what I want to show you is I've basically disabled the rest of the drives that we were not using. I've tested it on a 755 PowerFlex 755 as well, but I've also done this. I'm doing this now on a 525. Right, so PowerFlex 525 that we're using, there's a couple different variations. We are using the EENET, so that is what the tag name is, and I want to show you how you get to sync this up. And a small comparison that maybe you might be familiar with and you might not be familiar with, in Studio 5000 Logic Designer version 32, if you pull up the component or the actual device properties, you see it kind of looks like CCW. And why do I say that? Connected Components Workbench, right? Why do I say that? If you've seen the last few videos I did, we actually set up this drive in Connected Components. So, and we do that because of the peripherals and the variations and stuff of that nature. So it no longer really kind of works with, not so easily with Drive Tools anyway, or Drive Executive. So now this drive came in as a power, or not the drive, but the program came in as a PowerFlex, which is rated at a 480. And of course, our trainer here is just a 110 trainer, right? So we have a simple PLC, simple 110 scenario, nothing fancy. So we do have a 110 drive. So how do I sync that up? Okay, so a lot of people would think you just go into here, you change a couple things, and maybe it would sync up. Well, if you go right here and you edit peripherals, you're going to go into peripherals and you can upload. Okay, so when you upload, this is when you connect, and this is how you drive match. Right now you have to do this offline, right? You can't do it online, but you have to do it offline. But the cool thing too is you can enable ACD or ADC, which is your automatic device configuration. Now you can enable this where if, say for instance, down the road you had, or you set up, first you have to set up all your process directly into your control logic processor, just like we're doing right now. We have to sync everything up, and later down the road the drive goes out, right? And we plug the drive in, but when we change the IP address to match the IP address that we have in our configuration, the program would automatically prompt us to download to the drive, right? So it would prompt us to download to the actual drive. Now we're not going to do all that. We're just wanting to kind of briefly talk about this and how to set it up, and definitely how to do the upload and import, export. That's kind of pretty obvious, but it's pretty. I thought it was very similar, the look and feel of the way things are, right? Now I bring all this up to talk about the tag structure. Okay, so you notice the tag structure down here is the PowerFlex _ 525 _ EENET, right? So the two files that we're going to be pulling up, right, are the PowerFlex 525 right here, which is a function block, right? So the function block, and this is to work with the AOI that works with Plant Packs. This is the Plant Packs AOI. Okay, so this is the name of the actual. You have to first give it a name. This is the name that they currently are using, which is my _PF 525 _ EENT, right? And then they're using the data type, which is right here. Now, okay, so what is that data type? That data type is an add-on instruction, right, that is implemented with Plant Packs. So the rest of these, so just note that this is your top level. This is basically your tag name or your device name for that specific device. In this case, the drive, right? This is the drive's name. Now we can change that name if we want to and name it something else, but in this case we're going to keep it the same name as what it is. And the next section is the input and output. Okay, so the input right here is going to be a device type right here. Now this is just a device type. This is, if you broke down your user defined, you could see your inputs and outputs right here. This is the user defined data that comes along with that works with this AOI, right? So I say all this to say that this is what's needed for the actual drive. Now, the reason the formatting is done the way it is, so you have your tag of your tag name for your actual device. You have your input, right? You edit that. You make sure you do your correct data type. You have your output. You make sure you have your correct data type. And then you have your fault list, okay? Your fault list, again, is going to be another data type. Now, let me jump over real quick and show you how all this is linked together with the actual device, because that's really where the key focus should be. So how are we making this block talk to this drive, right? So that it can work with this block to make it work with, I believe it's this block right here, to make it work with this block, which I have down here. So again, you have to understand how all this is working together so that you can actually get that functioning. Now, again, so it's breaking down the components and understanding the way the structure is so that you can actually understand how to implement this to get this successful. Now, so keep in mind, we talked about the two input and output parameters, right? There are the tags that we need. If we looked at this, we looked at their tag structure. This tag cannot be, it cannot be modified. That's all they're just telling you, is it cannot be modified. This is the tag structure that comes with plant packs, and you probably could hack it up some way and modify it, but I believe that works really, really well with what they have right here, and that's probably the reason. So if you look at this, there's supporting logic over here. Now there's supporting logic in this rung, which is a ladder logic. Now, and I bring this up for the simple fact of this tag right here, which is the PowerFlex _ 525 _ EENET, is right here. So you're going to copy your device. You're going to copy your device parameter, or your inputs, your status word, into your actual tag that you made up here, right? Your tag you made in right here. You're copying that into there. That's where that transition happens. And if you looked in your actual I/O and you looked in your tag structure, which all I did was open up my controller tags, you come into your controller tags, you would drop down and you would find where your I/O is, right? And how you would understand that is you could look at your data types over here, and you could see the data type. Now this is an AB PowerFlex 525, and it gives me the input and the output, right? So this is the drive status, right? And the drive status, right, that's when we synced everything together. When you see me actually pull that up right here, and we synced everything together up here to make sure that it was right. So you get that when you get the tags right here. You get your input and your output. You get two sections. Okay, so talk about your inputs. You have your input word status, right? You have your 0 through 0 through 15, which is your 16 bits of input word. You also have your ready bit, your active bits, your command, your actual accelerating, decelerating, all of the bits you need, and your actual output frequency, right? Which is basically a decimal form. At that point, this is an integer. You can see these data types over here. The output word, again, that's going to be your command word. Now you can control a drive from your command word, or you can control it from your start, stop, jog, clear, and all the presets and accelerations and stuff like that. And this is also your frequency command, which again is an integer form that goes out to the drive. Now, why do I bring all this up? Now, I'm bringing all this up to show you the transition where all this ties in together, right? Because if you don't know where it all ties in together, then you're not going to be successful. Okay, so this line of code right here is very important because this ties in the inputs of the drive that we just got through looking at, ties in the whole input status to that my PowerFlex or my underscore PF 525 underscore EENET underscore I, right? So that's the tag we actually have in this function block, right? So that's the tag we have right here in the function block. Now in the ladder logic, we're going to show you right here. This is just a JSR jumping to that, and I actually pulled up the wrong one, so excuse that. Make sure you pull up the right one. Again, you gotta understand they're trying to give you many examples right here. So this is this is the JSR jumping to that actual function block up here. Now this is going to be your mask move. In the PowerFlex 525, you have to do a mask move, or normally you would just do a move. Like in a PowerFlex 755 drive, you would just move your word into the other word, right? You would move your command word into your command word, and you would move your frequency into your frequency, just like they're doing here. But in this scenario, they're doing a mask, and they explain this in this situation up here. But basically, they're talking about a mask move, and the reason you mask move, it's broken down into the documentation of the actual drive. But in conjunction with this, right, all a mask move is just a filter, right? So what are you paying attention to? In this case, what we're paying attention to is bits 1, 2, 3, 4, 5, and 6. So in this instance, all we care about in the paying attention to the mask or the command word of the drive, which is the start, stop, and reset and clear and all that. All we care about is the first 6 bits, right? So think about that. Now that's in the command word, right? So that's completely configured differently. So I say all that to say that when you're doing this, the output command, right? The output, which is, if you look at this tag, this is getting the output command is coming from your function block over here, right? So if your function block is right here, this right here is going to be your logical command, right? That's going to be that's where you're getting that. You're getting it from that tie, right? So if you think about the way things were talked about, and you think about the way things are, now how are we getting our connection? Now this is very important, and I know a lot of you guys may already have this, and some of you may not, so I want to make sure that this is 100% clear. So your drive to logic, then to HMI, right? But understanding the way that the tie works together, so in our case, we're going to the I/O, right? The I/O to ladder logic to function block to HMI. And I'll explain this. This is the reason why I wanted to actually talk about it, because when you spill it out like this, and right off first glance, you're like, well, that doesn't make any sense. But it does. If you think about the way everything we just talked about, the ladder logic, this ties into the I/O, which is down here, which is our drive, which ties into this function block, which ties back into the function block, makes the tie back to the actual drive. Then that talks to the function block is what talks to the actual HMI. Okay, so let's actually download this so you can see some action. Okay, so first and foremost, we're going to come in here and we're going to download this to our application, which is right here, and we're going to download this. So come in here and we're going to download it, and then we're going to actually run the application. I'm going to show you the way the application works. Okay, so it's downloading right now. You can actually see the drive is actually faulted out, but no worries, we're going to actually reset the drive when we actually crank up the HMI, so because it will fully work with plant packs, right? And that's the goal here, is to understand how you're doing it, but to also get it working. So with all this said, okay, so now we have our program in here, we have our drive. Now, what we need to do is come into our HMI system over here. First and foremost, you need to make sure your communication path is right. So our communication path, again, we set our shortcut is already PowerFlex. Our communication path is going to be right here, which in our case says traffic light because we did another trainer on traffic light, but sometimes there's a little cache in there that keeps that. No worries, it doesn't matter. And you just hit apply right here and you make sure you verify this. When you verify it, make sure the path is right and you hit OK. This gives you the ability to sync this up. So say if I wanted to open this up and I wanted to come in here and actually replace a tag, like tag substitute or something. If I wanted to tag substitute one of these, then I could come over here and refresh the tag, and then my PowerFlex online would come in, and you could see I can pick from my tag database, right? So in this case, my PowerFlex my underscore PF 525 ENT. This would be right here in this case, and then that's what it's actually looking for, right? So that's what we would put. Now I'm just showing you an illustration because I've already done that, right? I'm trying to show you the connected pieces and the connected components so that you understand the way this works. So you're probably wondering, well, this was pre-done, so how does that work together? Well, that's a very good question because you come down here to your PVSD graphic library. This shows you the breakdowns, okay? And this is actually this is the PlantPax version 3.5. So if you really wanted to see the version of what we're actually working with is 3.5. The same thing really applies to 4.1, except for they added I believe in 4.1 they added like a message instruction inside of the PlantPax. So if you looked, this is the one we're currently using. You can see, you can look at the definitions again to see what these are and see what you need to change out. Right, so if we broke this down and we went in and looked at it, global object default, you don't have the ability to change this, so we need to get to that ability. And it's not edit because that's not getting to that point. This actually shows the parameters right here. You see that? So the block is what you were looking for, right? So this shows you that we're only utilizing these. And now, say for instance, I want to say 0 down here. This would be 0 down here. I want to always show the faceplate. Okay, so that would be where you load these in. These are kind of layered. So if you think about it, this is just like this. All right. This is where you would load in your parameters. And your parameter definition, I'm sorry, your parameter definition is that's where we got it right here. So we understood our definitions of what we needed to put in the drive or in the component, the actual global object. We understand what we needed to put in here by the parameters that we're seeing over on this side. Now, in doing so, this over here, this screen, we have to understand the breakdown of it. So if you just pop this open, you just right click this and this is not there, it has to be a layer deep, a layer deeper. So just hit edit one time and then you can see that this is pointing to a different drive. Okay, so I'm gonna actually undo all this because I want everything to be working correctly. And what we're going to do is, now that we have an understanding of how we have everything tied together, I've made a client, and I want to actually run this client. So let's first save our screen. Let's go to our client. Let's run our client. I'll call this, I've made the client to save time so that you can easily see this. I'm going to show you the drive is currently in a fault status because we downloaded, right? So when you download, you naturally fault out anything that's connected with SIP motion or SIP connection, and this drive is connected. It was owned by the actual processor. So if the drive is owned by the processor and the processor changes states, yes, they have the variability to fault out. If now, again, you can set different things and you can set different components to reset and all you know, and have things work completely different. But in the instance that we have, when we download it, it'll be cause default. That's all. That's really what I'm trying to break down. That doesn't mean it's going to happen every single time, because we can change the way the setup is. Okay, so now that we have everything here, we're not going to worry about this because we're not connected to that. But we are going to show the PowerFlex right here, and you can see the fault code right here. So it says heatsink, which is the fault code that's showing. And we're going to reset the drive. We're resetting the drive. Now I'm going to show you that we can start the drive. So I'm going to enter in, let's just say, let's run it frequency at 25. Now, if you notice, the drive right now is not running, but it is reset. Okay, so now I'm going to actually hit start. The drive started, starts running. It ramps up to its speed. So now our faceplate's actually working with the actual system, right? So if we looked at this, we can go over here and look at all the parameters and look at the make sure everything's working accordingly, right? So we can change the XL, D cells and stuff like that if we wanted to, and change. I mean, there's so many different components to this that we could actually get, but you can see the trend is working, and it's actually running at 25 right now. Again, that layout, I have that. I need to actually disable this and put this on the front. I actually fixed this because my ActiveX was slightly different, so I changed the graphical. So naturally you wouldn't have this overlay right here. I changed it. If you looked, I'll open up another one just so you can see it. There's naturally a different hat thing that pops up right here, but the ActiveX is different. So what I did is I changed that to a numeric display. Just because for the simple fact of being able to do this edit, being able to do this and break down and then show you the components behind it, I wanted to show that working. And I actually have 4.1 running on the system as well, so I didn't want to interact with 3.5 being off when 4.1 plant packs was something I'm going to actually do some training on as well. So you can hit stop and it would stop. Now again, you can see it's changing color, it's doing everything, and I'm sure you can easily see we can go to operator, change the operator status. You can come in here and change the commands. You can put it in maintenance mode. So you can see that all this is fully functional. You can bypass all interlocks if you wanted to. It gives you full indication of what it's doing. So everything is working. And now hopefully by now you see the transition and the tie of the way things are working. So now let's just say if we go to 10, you can almost hear the drive running, I'm sure, in this video. But let's go to 10, let's start it back up, and we can see that the drive goes to 10. Now there's another key feature in this that I want to show you. In this actual application, right, in this actual application, there's a simulation. In the plant packs, the reason the rest of these drives look okay and they're not just red X like this one is, because I actually had this one attached to a PowerFlex 755. In the application, you have the ability to actually do a simulation test. So if I ran this right now, I'm not connected to this. It's not actually connected to a real device. It's in a simulation. Well, they'll tell you in 3.5, in the PDF for 3.5, how do you cut on and cut off the simulation? You would think that there would be a button right here on the screen that would be easily accessible. You actually have to go to a specific bit. Let's just say this is the PowerFlex 525 with E2P. Okay, so if you went into this, you would go right here. Now I would go here, I would open up the instruction logic. I'm going to show you where this is. So we're going to scroll down, because this is real logic, and you see this, there's a simulation bit in here. That's what they're using. So I want to show you this. This is in simulation right now. Now if I change the status, if I toggle this bit, this is no longer in simulation. You see it went into drive fault. So there's a way you can simulate logic. There's a way that you can simulate your blocks to make sure your tag structure is right, make sure your logic is right, make sure everything is working, and the only thing that is eliminated from this situation is your device, your hardware. Now, hopefully you guys stuck around and actually heard that, because there's a little trick to that, is you have to toggle that bit. And they tell you that in the PlantPacks module. So coming back, I can test any one of these just to test the actual bit. But they tell you right here to set, okay, all drives are in simulation mode. To set this bit, go to each AOI and set the inputs, I call it the input simulation, which is really what it is. But they have a little acronym they put, and then set that to 0. All I did was toggle the bit, just like you just got through seeing. And when it's in simulation, it has this little, almost looks like it's really a loop, is what they're trying to implement, like loop test. And what they're doing is giving you the ability to actually come in here and test your situation without having to do that. But in our case, we actually did hook up a drive. Okay, so I'm going to run it again. I'm going to pull it up. I'm going to let you see that it is running. Okay, so it is running. See how the running status. I can come in here. I can look at my drive. If I look at my drive word, my actual word is a 1. It's running. I'm sorry, my word right here, my command word is commanding 4. It's on. So, but the actual, you can see the actual status right here. The output is forward. The command, the frequency command is 1000, which is 10 hertz, right? Then my input status is the drive is active, or the drive is ready, it's active, it's command forward, it's command direction, right? So it's active. So let's see if we can change that. And I don't think this is too forward and reverse, but it's actually not. But we may be able to change that in like one of the parameters or something. Come in here, and it might be, I don't believe drive can be reversed right here. So let's stop it. Stop right here. Let's go right here and come back here. See if we can't check that box. Drive can be reversed, and you can see now it can be reversed. So if I swap it, now I'm going to go the reverse. So now it's actually going to go reverse of what it did. So you can see all that working properly. So I just wanted to actually show you that, because again, when it comes down to it, and let's actually look at this. It's running forward, running reverse. Let's actually run it reverse. And let's look back here and make sure it worked properly. So we're going to look at our direction, command direction right here. This is all actually working like it should, because the actual direction, command direction is 0, and that's proper. So if you actually stopped it and commanded it forward, this would be a 1. Okay, so this bit would be a 1, just like you see right here, right? So that's a good indication of showing you how flexible and how durable the PlantPacks application is, and how things tie together, right? And how things work together. Now, for those that are part of the actual channel, and they're actually members of the channel, we'll shut the drive off so I can speak. But for those that are part of the channel and are members, you can look in your community section, and all the files will be there for you to download. And you can actually download and use this yourself and be successful, now that I have explained the situation. And if you are interested in joining, there's a join button on the channel. You can just join, and join at the level that is share. The share level would be the second tier, which would be the bonus section, which we get to share the files. And I'll have all the files there for you to actually download. So if you want, and again, we'll close this out. I'll have all these files right here so you can actually see, and this will be current, right? So I've actually explained it to you. I've actually showed you how to do it. So if you get the file, so go to the actual community center or the community tab, go down, or even go to your membership tab and see all the posts, and you'll see that there'll be a section for this, and it will describe the downloads, and it will give you the ability to download the files. Now again, this is version 32, so I will warn you about that. There is no backing up from version 32 to version 20 or nothing like that. This is Plant Packs, so this is a local application, and this is Plant Packs version 3.5. So I will highlight that and notate that in the actual application and in the actual download section. And for those that aren't part of the actual downloads or are part of the member of this channel, then hey, this hopefully you got a lot out of this video, and you can go back and watch it again and see how maybe you can go back to Rockwell and get the files from them, and then actually implement this yourself. But again, for those who do have the files that will get the downloads, you can actually implement this and be successful with this as you want. Now again, coming back to that, I believe you can actually run this on an emulator. I've done that plenty of times before, so you don't actually have to have a processor. So don't feel like you need to have a actual PLC processor to do this. I have an L73 that I'm currently running, and an EB&T that I'm actually communicating through. You can actually do all of this and do all the nothing but simulation, right? Nothing but code simulation. You can do all the simulation and just do all of it through emulating, right? You don't have to have any kind of PLC or anything like that. Now, it's beneficial if you do have the components, but hey, we don't all have it. At a certain point in my time, in my career, I didn't have everything. I had to emulate everything. I had to simulate everything. And I honestly really feel that you learn a tremendous amount more when you have to emulate something than when you have to simulate it to get it to working properly. So with all that said, hopefully you got a lot out of this video, and I really do appreciate you guys' support. So we'll see you guys on the next one.